Hello, everyone. I'm a researcher at the Center for at CLTC UC Berkeley and a cybersecurity professional with over 7 years experience focusing on penetration testing and developing secure system architecture. And we're going to discuss the MITRE framework for cloud threat investigation. This is my colleague, Tanu.
Hello, I'm a graduate student researcher at CLTC UC Berkeley with 12 years of experience in security, cloud, IT operations, and user services, and I specialize in identity access management and cloud security.
Here is our agenda. We'll provide an overview of the MITRE attack framework and then discuss the current security landscape for cloud security before discussing how we can apply the MITRE attack framework, as well as any challenges that arise from implementation, and go over the survey that we conducted. Then we'll wrap up with our recommendations and a Q&A. So MITRE is a nonprofit cybersecurity think tank that developed the MITRE attack framework. They describe it as a globally accessible knowledge base of adversary tactics and techniques based on real-world observations. The attack knowledge base is used as a foundation for the development of specific threat models and methodologies in the private sector, government, and in the cybersecurity product and service community. Within the framework, we examined two matrices, the general enterprise matrix and the cloud-based matrix for describing cloud-based techniques. The attack framework consists of matrices, and each of these matrices contains 12 categories, 10 of which are shared across all matrices. The categories include initial access, privilege escalation, methods of persistence, how to evade defenses, and so on. Various techniques that attackers can use in attack scenarios. We encourage all our viewers to check out the MITRE attack website to get more of the details. Here we will highlight the common cloud native threats and discuss how companies are investigating cloud threats today, which my colleague Tanya will go over.
To answer this question, as part of our research, we conducted a survey. Our research was focused on analyzing the challenges that enterprises currently face in cloud security. And for a comprehensive assessment, we conducted a survey of security leaders, including CISOs, CIOs, CTOs, and security operation analysts across 325 large and medium-sized enterprises in UK, US, and Australia. 57% of our global survey respondents are large enterprises, and 62% have an in-house security operations center. We categorize enterprises with 5,000 employees as large and 1,000 plus as medium-sized. We targeted diverse sectors of our survey, including IT, technology, telecom, retail, transport, financial services, manufacturing, production, and other sectors. We investigated the challenges faced by security operations teams and evaluated the use and impact of standardized frameworks for threat investigation. We hypothesized that MITRE attack would be the most widely adopted framework, and the survey results validated the assumption. We interviewed 10 leading cybersecurity experts to further validate our study. Cloud computing enables any organization to pay to use hardware and software resources housed in cloud service providers' data center. Our survey indicates that across the industry verticals we surveyed, hybrid cloud is the most popular deployment architecture across all major providers. Among our survey respondents, Azure was more popular than expected, about 64% used Azure, and Azure was also most popular in all three market segments by a great margin. We hypothesize this is due to survey sampling in large enterprises and government agencies that we had. Currently, 3 service models represent the fastest growing sector of the cloud computing market. Although SaaS, the largest or most widely adopted, still Still, is SaaS the largest and the most widely adopted out of all three cloud service options available. While cloud computing provides the flexibility to choose from various service models in deployment architectures, it also presents serious security issues. These service models require varying responsibilities to be shared between the cloud provider and the customer. The IaaS model assigns the responsibility for the security of the lower layers like storage, networking, server, and virtualization to the cloud provider. The customer is responsible for the security of the operating system and everything that runs on top of it. In the IaaS model, the cloud service provider has the responsibility, which is basically minimum or least responsibility. In the PaaS model, the cloud provider is responsible for everything but the data and application, including networking, storage, servers, virtualization, operating system, middleware, and runtime. In the SaaS model, cloud service provider is responsible for everything related to security of the service that they operate. The greater the cloud service provider's control of the service model, the more security responsibilities the cloud provider has. However, in every service model, customer is responsible for configuring the service, managing user accounts, and critically protecting its own data. How is the SOC handling cloud threats? Just the
Yeah, thank you, Tanya, for that overview. When it comes to Security Operations Center or SOC, cloud is still a relatively new field of investigation. And there's significant issues with having a large team of dedicated cloud threat investigators and a lot of manning issues as a result. When we've then reviewed how these organizations investigated the threats in the SOC, and due to the distributed nature of cloud computing and how globally accessible it is for users in the internet, there's a complexity in identifying and investigating cloud threats across networks, endpoints, and cloud components used by the enterprise. We asked survey respondents to identify which event sources that they use, the cloud, network, or endpoint, to correlate data during threat investigation. Based on our interviews and qualitative assessments, we identified that the best practice is to correlate data from all three sources instead of trying to isolate and investigate threats separately. However, we only found that 2 in 5, about 39% of respondents, actually incorporate events from all three environments when they investigate threats. This presents a problem. According to a red team engineer that I interviewed, one technique that is used is to go after cloud administrators by phishing their on-prem workstations and using that to then compromise the cloud environment. So, and due to the popularity of the hybrid deployment, it's very difficult to separate these environments, which is why we recommend that all of it should be taken into account when conducting a threat investigation. Our survey respondents also observed that all 10 tactics in the cloud matrix were used, from initial access to cloud data exfiltration on a consistent basis, either monthly or daily. Organizations struggle with the multiple threat types concurrently. Each one poses high risk. Security operations teams function to triage and remediate these wide range of threats is difficult when they don't have a framework to prioritize and organize the threats that are on a constant barrage. We further investigated how security operations centers could integrate the attack framework and the value it provides. What we found is 81% of surveys respondents currently use the attack framework in general, with 63% using the enterprise framework, and another 63% saying they're using the cloud matrix. Among the respondents we surveyed, 83% find that it is comprehensively represents the adversaries and techniques they face. Among the survey respondents who used the cloud matrix, we found that 86 found that it comprehensively represented the threats they face on that end. We also investigated how well the level of adoption each enterprise is with adopting the attack framework and cloud matrix specifically. We divided the respondents into 6 stages, with some having no plans to adopt, with pre-planning stages, planning stages, early implementation where the attack framework is just used for knowledge management and references, intermediate stage where it's used for informed decision-making and automate some of the responses, and the most advanced stage, which is proactive threat hunting. From our investigation, we found that 44% of our respondents have successfully implemented the attack for cloud matrix at the intermediate to advanced stage, and another 44% are in the planning and early implementation stages. Due to this widespread adoption, we also looked at what purpose it serves for each organization that's driving this adoption, which is different. 57% of respondents cited that it was to help determine gaps in currently deployed security tools. Another 55% used it to implement security policies, and 54% cited threat modeling as one of the main uses for the attack framework. With all these implementation, with how well it's been implemented, there's still some challenges that are faced, which my colleague Tanu will go over.
Thanks, Jess. So we asked survey respondents to identify the challenges they observe while using the framework. 45% of organizations identified the lack of interoperability with security products while using attack. 43% cited the difficulty of mapping of events data to tactics and techniques, and 36% say they received way too many false positives. Some of these challenges could be solved by using security products to tag the events based on the attack framework. According to the security leaders we interviewed, there is a need for more products that tag events based on the framework. However, they also caution that mere tagging of events is not the sole requirement. Tagging of events with attack tactics and techniques helps identify which events should be prioritized by the SOC. For instance, exfiltration tactics should be prioritized over initial access. Based on our interviews with these security leaders, we found it's critical that individual organizations should conduct continuous testing to identify the efficiency of all the security products they use in order to identify all the techniques and tactics, sub-techniques associated with the attack tactics, such as initial access technique contains 3 sub-techniques. Continuous testing ensures that their products tag and alert techniques and also the sub-techniques. With these implementation recommendations, we further inquired our respondents about the future prospect of using attack framework. And based on our finding, of the large and medium-sized enterprises we surveyed, 63% use both attack for cloud and enterprise matrices in their current security operations center. 87% of survey respondents agree that adopting and responding using the attack for cloud matrix will improve cloud security in their organizations. 79% say it would make them more comfortable with cloud adoption. Further, 69% agree that they would be more comfortable outsourcing their security operations center to a third-party provider that uses the attack framework. Therefore, service providers that use the attack framework in their security teams and products may be perceived as better meeting their responsibility to secure the use of cloud services. Attack is widely used by defenders across industries and in government to find gaps in visibility, security tools, and processes. Cloud security still remains a continuously evolving landscape. However, most threats can be detected and prevented. We recommend that cloud threat investigation should be assessed holistically with the following building blocks. First, being adopting the attack framework for threat investigation. Our survey highlights the importance of adopting a comprehensive framework that can be used to identify the tactics and techniques used by the adversaries. Most organizations use the attack framework to standardize a common lexicon and taxonomy across the organization. In addition, the framework is most used to identify gaps in currently deployed security products or tools, guide security policy implementation, model threats, and assess the risks associated with adopting new technologies such as cloud services. Second would be investigate threats from all data sources. An important takeaway from our interview is the importance of maintaining visibility into events to detect threat patterns. Investigating threats comprehensively and correlating events from all sources, network, endpoint, and cloud are critical steps for successful threat detection and prevention. Only 2 in 5 survey respondents are currently incorporating all three environments together when investigating threats. A majority of those who have adopted the attack framework investigate both endpoint and cloud security events and threats together. Third would be to automate. Our research also found that security operations team face overwhelming number of investigations. All the security leaders we interviewed emphasized the need for automation, and they agree that automatic tagging of events using a security framework would be beneficial. We identify attack framework is most comprehensive for this purpose. Thank you. We are here for questions.
Yes, thank you so much. We'll be here for the rest of the session to answer any questions you have about our talk.